Welcome to this explainer. Today we're tackling the invisible force that can absolutely wreck your shotcrete placement before the nozzleman even pulls the trigger. Yep, we're talking about the weather. But here's the secret to really mastering this topic. You've got to view weather as a complete dynamic system, not just some simple thermometer reading on your job site. If you're prepping for your ACI Shotcrete Inspector exam or you're out there in the field grinding through quality control, getting this right is just absolutely essential.
Okay, let's dive right into this. We've got a great roadmap today. We'll start by looking at weather as a complete system, then hit the hard limits for hot weather, followed by the rules for cold weather. After that, we'll run through some real-world field scenarios, set up a rock-solid inspection framework, and finally, wrap up with your key takeaways.
All right, Section 1, Weather as a Complete System.
So before we get bogged down in the hard numbers, we really need to adjust our mindset. Environmental variables, they just don't act in a vacuum. As the code puts it, the inspector should think about weather as a complete system, not as a single air temperature reading. A single number popping up on your weather app, that doesn't tell you the whole story of what's actually happening to the moisture, the reinforcement, or the receiving surface on your specific site.
Moving right along, Section 2, Hot Weather Inspection Limits. Shooting in hot weather brings its own set of headaches, and the code actually gives us some very hard numbers to enforce. Now listen up, because here's a major exam alert. 95 degrees Fahrenheit. According to the ACI 506.2 tech spec, your shotcrete material temperature must never cross this line at the time of placement, unless you've got pre-qualification testing that proves otherwise. Pay close attention to the wording there. That's the shotcrete temperature, not the ambient air.
Now let's immediately contrast that with this number, 90 degrees Fahrenheit. This is the strictly enforced maximum limit for your reinforcement and the receiving surfaces. Guys, this is a classic exam trap because those values are just so incredibly close. So engrave this in your mind. Exactly 95 degrees for the shotcrete material itself, but exactly 90 degrees for the rebar and the surface you're actually shooting against. So why are we being such sticklers about these numbers? Well, high temps trigger a whole chain reaction of field problems. Hot material loses workability way faster, setting accelerates, water demand shoots up, and suddenly your finishing time is getting dangerously short. And what if you throw a strong dry wind into the mix? Oh man, those problems get exponentially worse. A receiving surface that you personally verified was perfectly saturated surface dry, SSD, just 20 minutes ago, it can become completely bone dry after a hot wind rolls through. You literally have to check it again right before placement.
All right, flipping this script, let's hit Section 3, Cold Weather Protection Rules. Let's look at the complete opposite extreme. When the temperature tanks, early freezing becomes the absolute biggest enemy of fresh shotcrete. I mean, fresh cementitious material is super vulnerable before it builds up enough strength. So the crucial point here is that the temperature trend dictates your required field action. If the ambient temp is 40 degrees Fahrenheit and climbing, you're good to go, green light to shoot. But if it's 40 degrees and dropping, shooting stops immediately, unless you've got approved protection in place. It's the exact same number, but it means two completely different things based on the trend.
And here's another huge exam alert for you. 50 degrees Fahrenheit. That is the minimum shotcrete material temperature at the time of placement. Also, and this really should go without saying, but it's a hard and fast rule, shotcrete must never be placed against a frozen surface. Ice literally acts as a bond breaker, and a cold surface will just suck the heat right out of your fresh mix.
So, what happens during prolonged cold snaps? When temps are expected to average below 40 degrees for more than 3 days in a row, we rely on this setup. Notice how thinner sections, anything under 12 inches, actually require a higher temperature range, specifically 55 to 75 degrees Fahrenheit. Thicker sections, up to 36 inches, they only need 50 to 70 degrees. Why the difference? Well, it's just basic physics. Thinner sections lose their heat much faster than massive thick sections. The code totally accounts for that.
Ultimately, the whole goal of cold weather protection is to stop early freezing in its tracks. ACI guidance uses 500 psi as the critical early strength threshold you need to resist a single freezing event. But hey, watch out for a really common misconception here. Hotter does not always mean better in cold weather. If you try to blast the concrete with excessively high heat, you're asking for rapid setting, slump loss, and thermal contraction cracking. The goal is a controlled temperature, not the maximum temperature. To keep those temperatures controlled, as the inspector, you've got to be all over monitoring the system. Here is your exact step-by-step workflow for the temperature log. You log the date and time, the specific location, the outside ambient temp,
the actual shotcrete temp under the protection, and finally, the weather and protection conditions. And when you're checking that actual shotcrete temperature, pay super close attention to vulnerable spots like corners, edges, and anywhere near enclosure openings. Those are the exact spots that are going to cool down and freeze first.
Okay, Section 4, Real-World Field Scenarios. Let's bring all these technical limits into the real world. Here's your first scenario, a bit of a mini mystery for you. It's a gorgeous sunny summer day. Ambient air temp is sitting at a very comfortable 88 degrees. The crew looks at you and says, hey, we're well under the 95-degree limit, we're good to shoot. But you walk over to the reinforcing cage that's been baking out in direct sunlight, point your infrared thermometer at it, and it reads 97 degrees. So, as the inspector, what should you notice here?
Well, the glaring problem is that the reinforcement limit is strictly 90 degrees Fahrenheit. Sure, the ambient air is perfectly fine, but that hot rebar completely fails the ACI requirement. It's a perfect example proving exactly why just checking the ambient air temp isn't enough. These limits apply to specific, individual items on site.
And this brilliantly illustrates our next scenario. Say the crew throws up insulation blankets to protect a wall overnight during freezing temps, but they get a little sloppy and leave a huge gap around one of the edges. The center of that wall stays nice and toasty, but that exposed edge is losing heat fast. As an inspector, you can't just check the cozy center of the blanket. You absolutely must evaluate the coldest, most vulnerable location.
Moving on to Section 5, the inspection framework.
To make sure you never miss sneaky details, like an exposed edge or some overheating rebar, you need a foolproof, standardized way to process what you see in the field. I want you to rapidly fire off these 4 questions in your head. 1. What should I see? 2. What am I actually seeing? 3. Why does it matter? And 4. What action is required? Let's say you see missing temperature records. You know it matters because early freezing leads to catastrophic failure. So your action? Require approved corrective procedures before the work goes any further. This logic keeps you sharp and totally objective.
All right, finally, Section 6, Takeaways and Next Lesson.
We've covered a tremendous amount of ground today, so let's wrap this up with the absolute most critical, highly testable points you need to lock in. First, track all your hot weather variables. Second, keep a close eye on cold weather trends and religiously check those vulnerable edges. And third, I can't stress this enough for your exams, apply the correct limit to the correct item. Do not mix up your ambient air limits with your material or surface limits.
Which brings us to your ultimate field takeaway for this explainer. Do not just inspect the thermometer, inspect the entire weather control system. You've got to look at the material, the environment, and the crew's procedures all as one big interconnected web. Master this, and you are going to prevent massive field failures. And that leads us perfectly into our next lesson on test panels, cores, and evaluation.
I'm going to leave you with this provocative little thought. If weather can change shotcrete this drastically before the material even has a chance to set, just how closely do you think you should be watching your test panels out in the field? Chew on that for a bit, and I'll see you in the next explainer where we dive into exactly how to evaluate those panels. Thanks for hanging out with me.